Hello, in this video we'll be going over some basic equations of motion questions. So in physics they basically discovered these equations that works for pretty much all of motion, anything that moves pretty much, and all forms of motion. So these are just three of the equations of motion. So the first one I'll just draw for you. S equals ut plus a half at squared. So that's the first one. The second one is v equals u plus at. That's the second one. And the third one that we'll be using in this video is v squared equals u squared plus 2as. Okay? So just to get you familiar with what each term means. So the S means displacement and uses the units distance. We'll unit some meters. U is initial velocity, and its units is meters per second. V is final velocity, and it also has the units meters per second. And A is acceleration. Sorry, I just forgot how to spell acceleration just there. I don't know if that's correct, but you know what I mean. Okay. So these equations, they apply to motion where acceleration is constant. So meaning the acceleration isn't changing pretty much. It's either an object's moving, it's accelerating at a constant rate, or deaccelerating at a constant rate. Its velocity can be changing because acceleration is the change of velocity with respect to time. So that's what each of these equations, this is what the three equations we'll be using in this video, and this is what each of the units, each of the letters mean pretty much. Okay, so let's get straight into our first question. So a tennis ball is thrown vertically upwards to a height of 4 meters. What is the ball's initial velocity? So let's just have an idea of what's actually going on. So we have someone here, and they've thrown a tennis ball, and it's gone up, and it's coming back down, right? And the distance it's gone up here is 4 meters, right? We want to know the initial velocity of the ball, okay? So straight off the back, we've been given S. Oh, actually, hold up. If you want to have a go at this question, feel free to pause the video. Alright, so straight off the back, we've been given S. S is 4 meters. We want to find what U is, so we don't know what that is. Now, if you throw an object upwards, it has to come back down, doesn't it? So we know what acceleration is. It's gravity. So acceleration is g, which is equal to negative 9.8 meters per second per second. When an object is thrown upwards, it comes back down. But when it's up here, it's at rest for a brief moment. So when it goes upwards here, so I'm just going to rub out some of this stuff here so I can draw a bit more. So when the ball is traveling up here, it needs to come to rest for a brief moment before it falls back down. Because as it's going up, it's got this force of gravity, so Fg, constantly pulling down the ball until up here, until up here it comes to a complete rest. So at this point up here, the final velocity is 0 meters per second. Okay? So knowing that fact, we have pretty much all the information we need to find the initial velocity of the ball. So for an equation of motion, if you have 1, 2, 3 things, you can find the other 2. Okay, so let's just write our equation. So we have S equals ut plus a half at squared. We also have v equals u plus at, and we also have v squared equals u squared plus 2as. Okay, so I've got my S, so I can use this equation or that equation. So I don't need this equation, so I'm just going to rub it out. We don't have a U, but both of these have a u, so we can rearrange it to find it, so we can still use either. Both of them use acceleration, but only the bottom one here has the final velocity, so we can't use the top equation. Right? So straight off the back, we're just going to use this equation here. So I'll just rub this out. So we've got these three terms, three numbers here. Move them over here. Yep. So all we're going to do is just substitute into our formula. So our final velocity, our final velocity is 0. We want to find what u is, so we'll leave that there. Plus 2 of negative 9.8. Oh, I've run out of room. Just going to move this across a bit. Negative 9.8 times by 4. Okay, so see what I've done here. I've put that into there, put that into there, and that into there. Okay. Alright, so this is the left hand side is still 0. So why isn't my thingy drawing? Oops. Sorry, having some technical issues. So 0 equals u squared. I'm just going to move all this to the other side. So rearranging all that, we're going to have u squared equals 2 times by 9.8 over 4. What I did here was change the sign here, because if I move it to the other side, I have to change the sign. So it's on this side it was a negative sign. So if I moved over here, it was going to be a positive sign. And since there's only one negative over here, when I multiply this out, it'd be a negative number. So I just got rid of the negative sign on here. Alright? Cool. Alright, so I've done that. So u square root that to undo that. So u is the square root of 2 times 9.8 times by 4. And this is all under the square root. Using your calculator, you'll approximately get 8.85 meters per second. Okay, so this number here is the initial velocity of the tennis ball that gets thrown up. So it gets thrown up upward at 8.85 meters per second. Okay, so that's what we found here. This could be like a whoops, that's the next question. This could be like I'd say this is a pretty easy starting question, but they don't get too much harder than this. Okay, so I'd say this would be a 2-mark question, so if you did all that, you get 2 out of 2. Alright, next question. A trolley runs down a track from rest before passing through a computer timer displaying its speed as 2.77 meters per second. The distance traveled by the trolley during this time was 1.2 meters. Calculate the acceleration of the trolley and the time taken for the trolley to travel the distance of 1.2 meters. That's a big question. I'd say this be about a 3-mark question. So if you want to have a go at this question, feel free to pause the video and have a go. Right, so straight off the back, let's start looking at what we have. So a trolley runs down a track from rest. Straight up, we know that its initial velocity is 0 meters per second because it's at rest. So I'm just going to draw a trolley, and it's got initial velocity meters per second, and it's going to go along this way, and once it passes through some computer timer, it will display its velocity over here as 2.7 meters per second. So just looking at our scenario, we can see it's accelerated quite a bit. So its final velocity here is 2.7 meters per second. So v equals 2.77 meters per second. Okay. The distance traveled by a trolley during this time was 1.2 meters. So we have another thing. Displacement is 1.2. So S equals 1.2 meters. Cool. We have 3 of the things, so we can solve this question. Now this question is asking for 2 things. It's asking for acceleration and the time taken. So we're looking for both A and T. They're both unknown. Okay, so I'm just going to write out our equation. So we have S equals ut plus a half at squared. V equals u plus at, and v squared equals u squared plus 2as. Alright, so first up I'm going to find my acceleration. So we can pretty much choose any equation for acceleration, but I'm going to choose this one because the rest of them have t, and we don't have a t at the moment, so I'm just going to choose the bottom one because that's the only one we can do at the moment. So v squared equals u squared plus 2as. So we're looking for acceleration of v squared minus u squared equals 2as. Divide by 2s. Divide by 2s. So acceleration is v squared minus u squared 2s. Okay, cool. Move all this into the corner here. So plugging into our terms into our little equation here. So acceleration is, so our final velocity is 2.77 all squared minus 0 all squared divided by 2 times by our distance 1.2. So plugging that into a calculator, our acceleration is approximately 3.2 meters per second per second. Okay. You might get 1.9, just round it up. That's what I did. Okay. Okay, so we have that information. So now we can find the time it took to travel that distance pretty much. Okay, so acceleration we know now is 3.2 meters per second. So our time, we can use either this equation or this equation. I'm going to use this one. So v equals u plus at. So v minus u equals at divided by a. So therefore t equals v minus u all over a. Therefore v equals 2.77 minus 0 divided by 3.2. So plugging that into our calculator, you should approximately get 0.87 seconds. Okay. So, actually, never mind. I'm going to move all this up here, so we have enough room. Boom. So now we've answered the question. We've found the acceleration and the time. So you get 3 out of 3. Okay. All right. Let's move on to the next question. A girl throws a ball vertically upwards with an initial velocity of 20 meters per second, then catches it sometime later. Calculate the time taken for the ball to return to the same height as it was released. Okay, so it's pretty much the same scenario as the first question, except we've just been given the initial velocity this time, so we don't have to find it. If you want to have a go at this question, feel free to pause the video. Okay, so straight up we've been given the initial velocity here. So we've been given 20 meters per second. So I'm just going to write this to the side. The best way to solve a physics problem is list what you have and list what you need to find. Okay. Then catches it sometime later. Calculate the time taken for the ball to return to the same height as it was released. Alright, so straight up the back, we're looking at this scenario here. So it has a ball. It's gone up and it's fallen back down, and we want the time taken, so the total time. So the time up and the time down. So total time equals time up plus time down. Now, since we're on Earth, if you throw an object upwards, the time it takes to go up will be the same time it takes to go down, provided you're just throwing it upwards on not in a vacuum. Okay, so the time it takes to go up, so time up is equal to time down. Okay, so all we got to do is work out the time it takes to go up and then times it by 2, pretty much, to find our total time. We know when the object is up here, its velocity is 0 because it has to come to a rest before it falls back down. So we know that v equals 0 meters per second, and we also know the acceleration is due to gravity, which is negative 9.8 meters per second. Okay? So all we're going to do now is calculate the time it takes to go up. So we're going to use, which equation? Alright, so let's write our equation. So first equation, v squared equals u squared plus 2as. V equals u plus at, and s equals ut plus a half at squared. Okay, so we have our initial velocity, so we can use any of these equations. We have a final velocity, so we can't use this equation down here, and we have acceleration. I'm going to use this one because if we use that one, that will give us displacement, but we want time, so we're going to use the middle equation. Okay. Rubbing that out now, and move this up here. Okay, so now we've got to rearrange for time. So v minus u equals at, divided by a, so t equals v minus u all over a. Therefore t, our final velocity is 0 minus 20, which is our initial, divided by negative 9.8. Putting that into our calculator, the time you should get is 2.04 seconds. Now, am I done? No, I'm not. So, what we've calculated here is the time it takes for the ball to reach its maximum height. All we've calculated is the time it takes for it to reach here. We want the total time. We want the time it takes to go down. And since we know that the time up equals the time down, our total time is just going to be 2 times 2.04. Okay? So our t total is equal to 4.08 seconds. Okay? Because the time up equals the time down, so therefore, since we've calculated the time up, we're just going to multiply that by 2 to get the total time. Alright, cool. Let's move on to the next question. Okay. A car is traveling at 10 meters per second. When the driver sees a hazard ahead and brakes, the car deaccelerates at 6 meters per second to a complete stop. What distance does the car travel while braking? So if you have a go at this question, feel free to pause the video and have a go. Right. So this question, I'd say, is it's gone a bit different. So we've been given given an acceleration, except we've been given deacceleration. So if you have a car and it's traveling at some velocity this way, and you're deaccelerating, that means you're accelerating in the opposite direction. So this is meters per second, and this is meters per second. So the acceleration is going in the opposite direction. So when you see the term deaccelerate in like a motion question, so in this one, the car is traveling this way at 10 meters per second initially. So this is its initial velocity. It's going to deaccelerate because it's going to come to a complete stop over here. Okay, so its final velocity is 0 meters per second. Okay, so our acceleration is going to happen in the opposite direction as the velocity vector. So v equals 0 meters per second. So therefore our acceleration is negative 6.0 meters per second. I use the different sign because it's going in the opposite direction to this. Okay? Which makes sense numerically and when you think about it as well. Okay, so we have 3 of our things, so we can find what we're looking for. So we're asking, at what distance does the car travel while braking? So I got the final velocity is 0 meters per second because this line here, complete stop. So it's traveling at 10 meters per second and it starts deaccelerating, so it's slowing down at 6 meters per second to a complete stop. Complete stop means its final velocity is 0 meters per second. So that's where I got that from. So alright, we have 3 of those, so let's write our equations. So we have v equals u plus at. We also have s equals ut plus a half at squared. we also have v squared equals u squared plus 2as. Alright? We have u, so we can use any of these equations. We have v, so we can't use this equation here. And we have s. But we want to find distance, so we're using this equation here. So v squared equals u squared plus 2as. We're going to rearrange to make s the subject, so v squared minus u squared equals 2as. Divide by 2a, divide by 2a, so s equals v squared minus u squared all over 2a. Alright, plugging in what we have here, so our final velocity is 0, our initial velocity is 10, and our acceleration is -6. So plugging that into your calculator, you should get a distance of approximately 8.33 meters. Okay. Alright, cool. I'd say that'd be like either a 3 or a 2. It's not particularly hard because we've been given a lot of stuff. So if you do all this, you'll get full marks. Alright, next question, fifth and final one. We'll just finish off with the easy one. So I'll just read it out to you. A stone is thrown upward with a velocity of 12 meters per second. How far will it have risen in 1 second? Take gravity to be 10 meters per second downward. Alright, so feel free to pause the video and have a go at the question. Alright, so very similar to the first question. Old mate's got something here and he's thrown it up and it's fallen back down. Whoop-de-doo. It's been given, he has a velocity of 12 meters per second. So straight up, u is 12 meters per second. We want to take g as -10 meters per second. I just take g as 10. I didn't put the negative sign to trick some of you, but gravity is always acting downwards. Unless you threw the ball downwards, you're just going to have gravity in the opposite direction. So if you're throwing something up, it's got a velocity going upwards. Gravity will counteract that because it's going in the opposite direction. Gravity always goes down. Therefore, this sign will always be the opposite of this sign. Unless you are throwing something downward, then this would have a negative sign here. But it doesn't, so it's got a positive sign because it's going upward. But gravity always goes down. So if you use 10 in your equation, you wouldn't get the marks. Okay. Alright, how far will it have risen in 1 second? So we've also been given time. We want we've given time is 1 second, and we want the displacement it travels. So v squared equals u squared plus 2as, v equals u plus at, and s equals ut plus a half at squared. Okay, so we've got u, so we can use any of these equations. We've got acceleration, and we've got t. So this is the equation we have to use. We can't use this one or that one because they both have final velocity, and we don't need it in this instance. Okay, so we're going to get rid of those, and we're going to use this equation here. Okay. So all we got to do is just plug into the formula because s is already the subject. So s equals, that's an equal sign, equals 12 times 1 plus a half of -10 times by 1 all squared. Putting that into your calculator, or you could just calculate it in your head. Let's just do it in our head. So 12 plus -5. So that's just going to be equal to 7 meters. So that's the distance it's traveled. That's not necessarily the max height. That's just the distance it's traveled when t equals 1. So it's after 1 second it's been thrown up. That's not necessarily the max height. So if you tried to use the max height, you probably would have gotten it wrong because we don't know if it's the max height or not after 1 second. Okay? Alright. So those are some equation and motion questions. If you have any questions, leave some in the comments, or yeah, pretty much. I'll be probably making another video on this because I've got 5 more equations and motion questions to go through. So yeah, I hope you enjoyed the video. Thank you for watching. See ya.